This is one of a series of 6 general higher tier revision videos for Maths GCSE. This is the probability one. It's probably the easiest of the 6. All of these are based on the resources from pixiemaths.co.uk, the revision mats that come with higher and foundation tier. Okay, so an electronic game can show red or blue or green or yellow. The table shows the probabilities that the colour shown will be red or will be green or yellow. Arthur plays the game. Work out the probability that the colour shown will be blue. So this is one of those tables which is a fairly standard question. Because they are mutually exclusive, they've got to add to 1. So to find this number in here, I do 1 minus all of the other numbers in the table. And whatever's left will be the probability for blue. Which is 0.2. Janice is going to play the game 50 times. Work out an estimate for the number of times the colour shown will be yellow. So an estimate because we don't know exactly how many times it's going to be yellow, but using the probabilities in the box, we've got this probability of 0.24 happening 50 times, so that is times by 50, and 12 times is the answer. Question 2, Josh plays a game with 2 sets of cards, set A and set B. Josh takes at random 1 card from each set. He adds the numbers on the 2 cards to get the total score. That is, adding the numbers on the 2 cards. Always look out for adding or multiplying. Complete the table to show all the possible total scores. So in this case we're just adding the numbers from each column. We're expecting some kind of diagonal pattern to emerge in this, as it normally does. 5 plus 6 is 11. 7 plus 6 is 13. 1 plus 8 is 9. 2 plus 8 is 10, etc. In this case, there is a diagonal pattern emerging. But it's not the way we normally see it, because normally we have the same numbers here and here, and in this case we don't. So it's a slightly different version of this problem. So that's the table completed. What is the probability that Josh's total score will be greater than 12? So we need to look at all of the ones that are greater than 12. We've got 1, 2, 3, 4, 5, 6 out of a total of 4 squares by 5 squares. That's 6 out of 20. So that's 3/10 or 0.3, but any of those answers are fine. 6 out of 20 or 3/10. So on to basics of Venn diagrams. 100 men who drink coffee were asked if they have milk and sugar in their coffee, and some of the results are shown in the Venn diagram. Complete the Venn diagram. So we've got 100 men in total. 12 of them don't like milk or sugar. So take away the 12, take away the 27 in that box, the milk box only, and take away the 21 that have both milk and sugar. Gives me 40 left, so 40 goes in here. So that's the Venn diagram completed. All we ever need is each section to be labelled. So, and always remembering that the outside the circle also needs to be labelled. Even if it's 0, you would put a 0 in there to make sure that everything is accounted for. What is the probability that one of the men chosen at random has milk but no sugar in his coffee? We're talking about this section, milk but no sugar. So that is 27 out of the total of 100. So 27 hundredths or 0.27. Either one is a correct answer there. What is the probability that one of the men chosen at random has no milk and no sugar in his coffee? So this is, we're talking about neither milk nor sugar, because it's an and, so no milk and no sugar. That's 12 out of the total of 100. Also 6 out of 50 or 3 out of 25, or 0.12. Again, any version of that answer is going to be fine for that. Set notation and set theory. Here we've got a set. The universal set is all of the numbers from 1 to 12, all of the integers 1 to 12. S is the circle for square numbers and E is the set for even numbers. So completing the Venn diagram, I would think first of all about what needs to go in the middle, any square numbers that are even. So square numbers, I've got 1, I've got 4, I've got 9, and that's it for square numbers. The only even square number is 4, so that goes in the middle. The other square numbers, 1 and 9, and now I've got rid of all of my square numbers. Good idea to cross them off as you go so that you don't accidentally enter them twice. Then we've got even numbers, so I've got 2, 4's already accounted for, 6, 8, 10 and 12. And then finally the ones that are neither even nor square are 3, 5, 7, 9's already taken care of, and 11. They can go anywhere outside the circles, as long as they're inside the box. Write down the probability of S. So probability of S, we just want the total number out of the total available. So we've got 12 numbers available. Probability of S is everything in S, so that is 1, 2, 3 possible values out of the 12. So that's 1/4 or 0.25. Probability of not E is everything outside of E. So that little dash means not E. So I've got 1, 2, 3, 4, 5, 6 possibilities outside of E, which is a half. Probability of S intersection E, that is the bit that is in both S and E, it's this middle bit, intersection. So intersection is just 1 out of 12. Okay, moving on to probability trees. An ordinary fair dice is rolled. Complete the tree diagram for the dice landing on the number 4. So we're presuming it's rolled twice because that's what we've got on the tree diagram. These are independent events. What I get on the first roll doesn't affect what I get on the second roll, and that means that the probabilities remain the same for the first and the second roll. 1, 6, 5, 6, 1, 6, 5, 6. Work out the probability of the dice landing on 4 both times. We take this route where it lands on 4 and 4, and we multiply along the branches of any probability tree. So we've got 1/6 times 1/6. Probability of the dice landing on 4 both times is 1/36. I wouldn't convert that to a decimal because a decimal would be much more complicated than that fraction. Question 2. A team has 7 boys and 3 girls. Stevie chooses 2 of the team at random. Now this is the one where even if they're being chosen at the same time, we have to list it as if one person is chosen and then the other. These are not independent. This is conditional probability because once one of them has been picked, of course, that person cannot be picked again. So in the first pick, we've got 7 out of the 10 are boys and 3 out of the 10 are girls. Second pick, if a boy has already been chosen, there are only 6 boys left to choose from and only 9 people left to choose from. A girl hasn't yet been picked and therefore it's 3 out of the remaining 9. If a girl has been picked, there are still 7 boys to choose from out of the 9, and there are only 2 girls left to choose from out of the 9. So that's the completed probability diagram. We know that all of the pairs of branches, or if it's 3 branches, each set of branches should always add up to 1. So always check that your branches add up to 1, and if they do, then you've probably done the right thing. Work out the probability that he chooses 1 boy and 1 girl. Well, that can happen in 2 ways. Either it can be boy followed by girl, this branch here, so we've got 7/10 times by 3/9, which is 21 out of 90. I wouldn't simplify it at this stage, I'd just leave it as it is because we're going to be adding things later. The other way of doing it would be picking a girl followed by a boy, which is 3/10 times by 7/9, which is also 21 over 90. And so to find out the probability of either of those things happening, we just add together those 2 probabilities. So if we're ever using more than one option from the end of the tree diagram, we will add whatever probabilities we've reached at the end of the tree diagram. So that is 42 over 90, which can be simplified. You don't have to simplify on probability in general. That is 7/15. And again, I would leave it as a fraction, not as a decimal. And that is the end of the fairly simple probability sheet.